presenting my project, which is a snake game implemented on Zynq SoC platform using hardware and software co-design. The system is divided into two main parts: the processing system, which is our ARM processor, and the programmable logic, which is our FPGA board. This is our hardware design. The core component is our Zynq processing system, which runs the C program and controls the overall system. Connected to it is AXI interfaces and several hardware modules. First, we have custom snake tracker IP. This module is responsible for maintaining the position of snake segments. It continuously updates the movement of our snake in real time and provides the current position of head and body to the processor. It also helps detecting conditions such as collision with our own body and interaction with the prey. Next, we use an AXI timer. The timer controls the speed of the snake. By adjusting the timer value, we can increase or decrease the game speed dynamically as the score increases. We also use AXI GPIO, which is connected to the push button of ZedBoard. This allows us to implement user interaction such as pausing and resuming the game using a board. Another important component is the AXI VDMA, which stands for Video Direct Memory Access. This module continuously reads our pixel data from frame buffer stored in our memory, which is our DDR memory, and sends it to the display interface such as VGA or HDMI. In my case, I am using VGA. This enables smooth real-time rendering of game without heavy CPU involvement. Also, the DDR memory acts as frame buffer, where each pixel of screen is stored. The processor updates this memory, and the VDMA reads from it to display the output. These all my codes are executed through this RTL block diagram.
Now I'll explain briefly about my main software components and codes that I have used in this project. Uh, this is my main file called gametop.c. This is the core file where the entire game logic is implemented. It initializes video system, interrupts controller, and snake system. Then it runs continuous loops where the snake position is read from hardware. The snake is drawn on screen and collisions are checked. The score and size are also updated. It also controls game speed using timer, and it also controls prey generation over the period. And then it also controls over conditions, like whenever the game is over, this program handles it. This is my snakec file where all the logics are there. I'll explain it later. This is the video.c file. This file handles the display system using VDMA. It initializes the video pipeline. It connects the frame buffer to the display, ensures smooth and continuous outputs. This is the graphic.c file. This is responsible for all the drawing operations, like drawing the snake body and head, drawing prey and frames and borders, and then printing text like scores. It works directly on the frame buffer at pixel level. And then there are several supporting files like graphics.h, which defines color and screen properties, snake.h, which contains function declarations, and video.h, it contains video related definitions. And then there is last one called font.h, which is used to render text on screen. So I'll explain my game flow. Like the game works in a loop. The snake position is read from hardware, then snake is drawn on screen, then prey collision is checked, and the score and size are updated. And then the new prey is generated. This will continue until collision occurs and the game ends. And this is the snake.c file. So first, the first function is the first function initializes the main structure, like it stores video buffer pointer, snake tracker base address, then GPIO base address and timer base address. The next function, controller function, it initializes interrupt controls, controller like which is GIC. Then it registers interrupt handler, enables exceptions, and it is very important and required for proper system operation. So next is our display function, which is show game over, which displays game over message and restart instruction. This function is used to clear the screen. It displays snake title, and it also shows our countdown from 3 to 1 when game starts, and it clears the screen again. It is used at start of the game. The next function is update score, which converts score to string and displays updated score on screen. This is the next function called get prey position, which generates random position for prey, uses timer value as seed, and ensures prey stays inside the frame. Next is the draw prey function, which sends prey position to hardware and draws prey on screen. This function connects the hardware and display. This is the pause button, which I have implemented, which pauses the game, which was not there before. This button is used to pause the game whenever you want and what will say and play it whenever after pausing. This is what I have implemented. I'll talk about it. Before that, there is this wait restart function, which waits until button is pressed and it is used after the game over. So coming back to this check pause, it reads button inputs. It toggles pause state. Like if it is paused, the if else conditions, like if it is paused, the timer stops, displays the displays paused text, and if resumed, it is the texts are cleared and restart the timer. There are other hardware interaction functions such as update snake size. It sends new snake length to hardware. There is next function called snake position, update snake position, which sets initial snake position. The next function is reset snake tracker, which resets our hardware snake tracker. The next is restart snake tracker, which resets internal read pointer, and so on. Now, coming to the features that I have added newly to the program is first is the pause feature. As I said, I use the center push button on ZedBoard, which when pressed, the game pauses by stopping the timer. When pressed again, the game resumes. And I also displayed a paused message on the screen and ensured it disappears correctly when the game resumes. The second feature that I have implemented newly is the special prey feature. Like after every 5 points, a special prey appears. It is shown in a different color, and when the snake eats this prey, the score is increased by 2 instead of 1. Well, and snake size is also increased by 2 blocks. This adds an extra level of difficulty and excitement to the game. Now, coming to the problems that I have faced implementing my project, are a few of them are hardware challenges. Like initially, I faced difficulty in working with hardware design in Vivado. The project was provided as a set of files from GitHub. There was no direct RTL block diagram file available. I did not. I also did not know how to reconstruct the design. Later, I understood that the project uses a TCL script. This script recreates the entire block design automatically. I had to search for the TCL script properly. After running the script, I was able to generate the block diagram, understand how difficult IPs like snake tracker, timer, GPIO, and VDMA are connected. So, and the software problems that I have faced are frame buffer glitching issues. Like initially, when I was continuously redrawing the prey every frame, this caused pixel glitches and multiple blocks appearing on screen. Then I realized that VDMA continuously reads the message memory and the CPU was writing at the same time. This caused frame buffer tearing. So how I solved it was I changed the logic to draw prey only when it changes, and then I removed all the graphical glitches by drawing the prey only. The hardware software synchronization was another issue that I have faced. When I introduced special prey, the snake was not detecting it. The score was also not increasing, and even the size of the snake was not increasing. Then I found that I was only drawing prey using software but not updating the hardware. To solve this issue, I have used the draw prey function. This sends prey position to hardware and draws it. Now both the hardware and software stayed synchronized. The next issue that I faced in software is game freeze at higher levels. Like whenever the game was reaching at level 20, the game stopped moving. There was no prey appearing. The snake was just moving randomly. So the issue for this was the prey was being detected multiple times, and the system thought the snake was eating continuously. How I solved this issue was I introduced a flag variable called prey eaten. This ensured play is consumed only once. The next issue I have had is relocation issue. Sometimes prey was generated inside the snake, hardware moved it automatically, but it was not updated on the screen. How I solved this was I added a logic to redraw prey after relocation, and and this kept the hardware and display synchronized. So after solving all these issues, the game ran smoothly. No glitches or freezing issues happened, and special prey worked correctly, and hardware and software were fully synchronized. This project helped me to understand real-time embedded systems, hardware software co-design, and debugging complex synchronization issues. Thank you. Now I will be showing you the implementation of my project.
So hello, this is my execution of my project. This is the monitor screen which we are going to display using VGA port. Uh, this is my ZedBoard. These are my controls: left, right, up, down, and center. This center is used for starting and pausing the game. This is my screen, and here is the score tracker. This is my code which has been dumped in my ZedBoard, and now I'll be playing this game and showing you how my game really works. So center button to start the game over. Timer is running. The countdown is 3 to 1. So I am controlling the snake using the buttons, as you can see. So my score is 1 as I have eaten one prey. Now my score is 2. So it goes on. So this is the fourth prey. Now after every fifth prey there will be a special prey that will increase my score by 2 units and my length of snake also by 2 units. So my score is 7 now, and the length has also been increased by 2 units. So this will continue till we get the multiples of 5. Now I have paused my game using the center button. Now I'll resume my game. As you can see, my game has been resumed. This is ninth,
and this is the 10th. After this, the speed of my snake will be doubled. As you can see, the speed has been doubled, and this is a special prey. Now after 20, speed will again be doubled, as you can see. Now this is game over. Now to resume the game again, I have to press the center button. So this is all about my project. Thank you.